For sure. I don't know why that TV will not work. All right, so did you all get an email from me yesterday afternoon? I just wasn't feeling ready to start a new topic. If I wouldn't have kept this class being dealt with rhythm and meter, I would have had to start atonal theory already today, and I wasn't quite ready to do that. So I think I'll just talk about rhythm some more, since I didn't really feel like I had enough time to finish it adequately last class, and then we can start the new topic of atonal theory on Monday next week. I do have a new assignment sheet. I guess I might as well give that to you now. I updated it a little bit, so there's only a few weeks left, as you know, but I did it anyways. So before I forget, I'll give you that right now. And you can cross out the old assignment sheet. Okay, so there is no homework due officially today. The homework that was originally assigned for today, would you please carry that over and have it due on Monday? Okay. So just to recap, workbook, where is it? Workbook pages 291 and 292. Those two workbook pages are due on Monday. If I left my workbook upstairs in the office, I must have done that. And hopefully by the end of this class, we'll have enough, all of the rhythmic information you need to be able to complete that assignment, no sweat. So I'm going to put up on the board, I'm going to put up the 8 terms that I had, was hoping to talk about last class. I'm not going to go through all of them again, but I am going to put up the terms just to refresh your memory. And I'm going to probably pick it up, my discussion of that with metric modulation. I feel like we could spend a little more time on that, and then I'd like to go through added value rhythms, and I'd like to go through non-retrogradable rhythms. And hopefully by that time, that should be enough. So, you may recall last class, I talked a little bit about something called asymmetric meters. And we had said that asymmetric meters are time signatures or meters with an odd number as the top number, with the exception of triple meters. So 3 over something in a meter signature and 9 over something is not going to be an asymmetric meter, because those are considered triple meters. But anything with the top number of a meter signature with the top number of 5 or 7 or 11, things like that, that is bound to be an asymmetric meter signature. And the asymmetric meter should be evident by the fact that The division of the beat cannot be only compound or only simple. It can't be consistently one or the other. Usually you have a little bit of simple division and compound division, even within the same measure, in the asymmetric meter. Some beats need to divide into 2 parts, some need to divide into 3 parts, in order to get the odd number of divisions or beats to work out in the meter. So that's asymmetric meter. Composite meter was another term briefly talked about. And I just remember composite meters as being a meter signature where you have something plus something over something. It's basically an irregular grouping of the bar in an otherwise regular meter. And again, it's usually given away by something plus something, or several things added together over a particular number for a meter signature. Mixed meter. We can describe very briefly, succinctly what was mixed meter. This one I think is easy if you know what it means.
Is that the time signature changes?
Yeah, it's very frequent, rapid time signature change. So you might have a time signature in one measure, the very next measure will change, the very next measure will change. If you have a bunch of time signature changes within a short span of time, that's what we refer to as mixed meter. Mixed meter. Displaced accent was another thing we talked about, and that's really not that hard to recall or remember. It's basically placing accents on normally weak beats of the measure, a normally weak beat or multiple weak beats of a measure. You're basically going against the normal accentuation pattern of a meter, so you're not going to be accenting the downbeat of any meter probably. You're just going to be accenting the weak beats, and that's just a nice way to think about displaced accent. Then we had talked a little bit about polymeter, and that's just where you have more than one meter operating at the same time in different parts. So for instance, one line or one part of music might be in 3/4, the other part or line of music might be in 7/8, and it's happening or occurring at the same time. So polymeter means more than one meter signature, more than one meter occurring at the same time. All right, then metric modulation. This is kind of where I wanted to spend a little more time. Well, I could write it on the board, I suppose. I can't get the TV to work. Let's see if I can put a short example of metric modulation on the board. Anytime you see a rhythm where there is some kind of rhythmic equation listed above a few of the measures or somewhere above the step, that gives away metric modulation. Metric modulation. Did anyone in their notes last time take down the forward definition for metric modulation? Yeah, proportional changes in tempo. Okay? So basically, again, we're saying that one note duration, a note duration in one measure, so for instance the 8th note in this 2/4 measure over here, is equivalent to another duration located in the very next measure. So we're saying that the speed or the tempo of the 8th note in this 2/4 bar is going to be the exact same speed and tempo of the 8th note in the very next bar, which is in 6/8. And what this is going to do is this is actually going to slow the beat down as we go from this measure to this measure. How do I know that the beat is going to slow down? Well, if the eighth notes are constant, the eighth notes remain the same tempo throughout, and there's 2 eighth notes to a beat in these measures, but there's 3 eighth notes to a beat in these measures, doesn't it make sense that the beat is going to be, it's going to take longer to get through a beat in this meter because there's 3 eighth notes rather than 2 eighth notes to every beat. So in other words, the beat might be going 1, 2, 1 and 2, and then you have to think 1, la, li, 2, la, li, 1, la, li, 2, la. You see how the times that I'm tapping on the board gets slower. Anytime the beat, it takes more time for the beat to occur. That's when the tempo slows down. When the beat gets very quick, and many beats occur in the same number of times, the same time span, then the beat is said to, the tempo is said to speed up or increase. So I guess what I'd like to do is I'd like for us to clap this rhythm. And what we need to do is mentally, as we're going through this rhythm, keep in mind the constant speed or tempo of the eighth note. The eighth note speed does not change. Okay? So let's go ahead and clap this rhythm. How about a tempo of 1 and 2? Right? Okay, so definitely the beat is slower here in this measure than it was in this measure. There are also trying to formulate something in my mind off the top of my head, and I'm not sure it's going to work. Let's say that the speed, if I did this example, let's say that the speed of the eighth note was 60. You know what, let's change that. Let's change the speed of the eighth note to 120. If we're doing a tempo of 120 eighth notes in 1 minute, what is going to be the speed or the tempo or the rate of the quarter note? 60, right? Twice as long. All right, now, as we go to this measure over here, let's see, 60 is the quarter. How long, there's a way to do this mathematically, how long is the dotted quarter going to be in a 6/8 measure, knowing that the eighth note is still the speed of 120? Would we know how to calculate that? They say that one more time?
Add the 120 and 60 and divide those by 100.
Add the 120 and the 60, and you're going to get 180. Okay, that's how long it's going to take 3 eighth notes.
You have to divide by 2. 180 divided by 2. What does that do?
What do you just find the
And see, this is what happens when I don't play. I was thinking about doing this real quick. I wasn't planning to do this for fun. This is 240. This is 240. So what's 240 plus 120? 360, right? So it would take, this would take 300. Or divide by 3. You're going to get 40. Yeah, so the beat, is that correct?
Yes.
The dotted quarter note is going to be 40. Because if 1 eighth note is 120, and 2 of them is going to take 60 to get through 1 beat. And if there's 3 of them in 1 beat here, you divide by 3, and it's going to take about 40 to get. there's, this is not a very good example, but there are ways to do this mathematically when you have a rhythmic equation above the stack. And you can actually calculate the exact tempo of something that's coming up. Just given a metric modulation, you can calculate the exact tempo of whatever the beat is going to be before you even start performing that. Because you can do it mathematically and figure it out. All right, so I guess we don't have to get too far in depth into metric modulation. I just wanted to make you aware that that's kind of how that works. The next thing I want to talk about is added value rhythms. I didn't really get a chance to treat that adequately last time. So put that term up here. Added value rhythms. Okay. Sorry, I couldn't sound the key. Let's see if there's any success. I really would like to show you something. That one seems to be working just fine. I don't think a different input is going to change anything either. I think HDMI 4 is usually the clearest one. Certainly the clearest one, but for some reason it just doesn't. Does anyone want to mess around with this and see if they can get it to show? Did this happen last time? Okay, maybe I'll have to just write it here. You know, I've tried turning the TV off and on again. I've tried different inputs. I know the correct input is here because it's showing on that TV, and I know that this is on, so it should have a signal. I just don't understand why it's not. Yeah, right. I don't know, is it plugged into the wall?
I will get a chair and get up there.
Yeah.
Wait.
Okay, let's start with this. Added value rhythm. Rhythmic irregularity that's created through the addition of a note or a rest to a rhythmic figure. So for instance, if this is my original, if I start with this rhythmic figure, 4 beats, and this is actually in your book on page 496, and then I actually change that rhythm slightly by giving us something like this. What has been added or what has been changed to this rhythm compared to this rhythm? It's pretty obvious, right? I've added a dot. Okay? So in added value rhythm, something is changed slightly from the original, and whatever is changed or added, a plus sign is used to mark the addition to something that has been added to the rhythm. In added value rhythms, the addition of a note value can be accomplished actually by adding a new note. It can be accomplished by adding a dot. It can be accomplished by adding a tie, or simply changing of the note's duration to a longer value. All of these things are possible to create rhythmic irregularity from something that was rhythmically regular before. So let's try another thing, according to what the book has. What if I did this? And again, always compare it to this first one right here. How does this rhythm differ from the very first rhythm? The 16th note has been added. How does this rhythm differ from the first rhythm? The rest has been introduced, so that's the new thing. And then finally, the last example that the book has is something that looks like this. how does this rhythm differ from the very first rhythm? Well, I hope you see that this 16th note in this time has been added. So we mark the addition, whatever has been changed from the regular rhythm, whatever has been added to make it irregular, we mark it with a plus sign. Anyway, I guess we should just give it up and give it up and give it up. Thanks for trying.
I think I'm playing.
Are they what, Kelly?
You wanna,
Yeah, I don't know. I mean, what I could do is I could shut off the power to everything and then turn it back on. You can see if that works.
try it.
Right?
You gotta start this with-
You know, I know next semester we're going to be moved to Brandenburg Education Building, but and I don't know what the technology's like over there, but I hope it's better.
You have smartboards.
It's consistently bad.
You're gonna have smartboards.
Well, your smartboard back up.
There we go. Now we'll take one.
Now you have the signal shut off.
That's because this is
No,
not
it's not
on,
on.
so let's try to turn this on again.
You just like. You just like.
Hey,
There it is.
You said you just
it's so blurry, it doesn't make sense.
Oh, that's weird.
There we go. Okay. Yeah, so this is what I was talking about here. Oops. So let's move this out of here. One second. Move this down just a smidge. There we go. And then freeze it here. Okay, so part of your homework is probably going to have something like this. In fact, I think it's on the second page of your whatever workbook. Yeah, it said it gives you a rhythm, a regular rhythm, and it says consider this rhythm, and then it says look at all these different ones, mark the part of these new rhythms that make it irregular or that actually been added that change the regular rhythm of the ball. And I had one student one year. The directions say, start with the beginning, it says, consider the following rhythm. And I had a student write on their paper, consider it, considered. And that's it. I thought that was kind of funny. Okay, I've done what you asked her, I've considered it. And that's basically it. So I try not to ever word that in any of my instructions on tests or quizzes or anything. The other thing I wanted to show you was, you know what, I don't know. I'm afraid, if I try to play this from YouTube and I choose a different input source, I'm afraid that this I'll never get back.
No, I have faith.
You have faith?
I have faith. You can blame me if it doesn't work. No, it's okay.
Well, maybe I'll give it a shot. One thing that I did not mention last class, and I don't really feel it's super important to put down in your list of terms for rhythm of 20th century, but one term is something called ametric music. Ametric music. Music that lacks any perceivable meter is called ametric music. Music that lacks any aurally perceivable meter. And this is supposed to be an example that the book uses of ametric music. Yeah, I know there's a time signature out there at the very beginning, but it does not seem to apply a regular series of recurring pulses, and as it says up above, for example, and so therefore it may be described as ametric music. I did find a recording of this piece on YouTube, and it's just a flute solo, and I guess when I bring it up and you listen to it, you really, I can't really hear any kind of a downbeat or anything like that, any kind of recurring metric pattern. It just seems to be, you know, kind of nebulous. So if you give me a few minutes, I'll see if I can bring that up. And I can't show it at the same time and play it, but this is on page 495 of your textbook. Well, at least you can see something. That's a good sign. Do you feel any kind of regular sense of pulse? I don't really know where the downbeat is. I don't feel any regular accent pattern. And that's probably far enough. I find this piece interesting because it was composed by a composer named Varese. And it says it was written in 1936 at the request of some guy for the inauguration of his platinum flute. So apparently he had a flute that was made out of platinum. And it says here, and I'm not a chemist or I don't know anything about this, but it says 21.5 is the density of platinum, that element. And so the name of this piece is called density 21.5. Oh, weird. Is platinum one of the elements on the periodic table? Oh, on the periodic table? Well, whatever 21.5 is measured in, I don't know what the units are, but that apparently is the density of platinum. And this guy, back in the 1930s, had a flute made of platinum. So the composer wrote a piece for his flute and he called it density 21.5. And it's an example of ametric music. A lack of any orally perceived regular kind of meter or anything like that, any perceivable meter. So that's kind of interesting. If you ever want to write a composition, be very creative and think about what you want to title it. There's lots of things you can title it based on whatever. Okay, let's keep moving on here. The next thing I'd like to talk about is non-retrogradable rhythms again. One of the non-retrogradable rhythms that your book uses as an example looks like this. A non-retrogradable rhythm is a rhythm that sounds the same whether it's sounded or played forward or backwards. Non-retrogradable rhythms are in essence rhythmic palindromes. A long word. Non-retrogradable. I think that's right. When it comes to rhythms in 20th century music, something is considered retrogradable if when you play it backwards it sounds different than when you play it forwards. So in other words, this right here is a retrogradable rhythm because when you go backwards, it sounds there's something new, something different you get than when you play it forwards. That's retrogradable. When you don't get something different or new when you play it backwards and forwards, then it's non-retrogradable. It's a rhythmic palindrome. And this, as you can see, is performed when you perform it forwards, left to right, or backwards, right to left, is going to sound the same either way. And that is a non-retrogradable rhythm. Let's see here. What if I asked you, I did this on, I don't think, the test that you guys have. No, maybe you have a question like this. If I asked you to use, let's say, to use these note values only, a half note, a quarter note, and an eighth note, and come up, you need to devise or write your own non-retrogradable rhythm. And you have to use at least these three durations, you have to use them at least once. What could you come up with? Who wants to start? Quarter note, okay. Eighth note. How about the half note next? Okay. There you go. There's a non-retrogradable difference. You were given a certain number of durations. You were told you have to use each of the durations at least once. Write your own, make up your own non-retrogradable rhythm. And this one sounds exactly the same as you play it forward backwards. I'm trying to think if I had a question. Maybe there's a question like that on the final exam. I can't remember. There might be. All right. So, does anyone have any questions? We're going to do some examples out of the book. So, examples very much like your homework. Does anyone have any questions about any of these terms that we've talked about? Yes. Like what I need for in this one?
Yeah, so we have another half month right there, so that half month?
Like this one?
Yeah.
Yeah, that would work too. Still sounds the same. Yeah, as long as it's symmetrical, I guess, say, or balanced about a central axis. I don't know if those are the right terms, but that's basically what you need. Yep. Okay. Switching this. I'm going to see if the document panel works again, because if so, do I have it missing? Haha. Like this. You know, just like you guys, I bet you many times you'd like a desk that's at least twice the size that you have. I would like a station here that's at least twice the size to fit all the stuff I need on and so forth. Okay, let's start applying this information. So enough talking, right? Enough lecturing about it. It says here, rhythmic procedures. Which of the rhythmic procedures that we've talked about in this chapter are illustrated by the following examples? And let's see, does it give you any? It doesn't even give you multiple choice. Well, that's okay, because you have a list of 8 terms. Letter A. What would you say that is an example of out of the 8 terms which I don't have on the board anymore? Asymmetric meter. That is correct. Do you know why? Because the meter signature is 5 over 8. And there's really no other one of those 8 terms that we talked about that fits that example any better. Okay, so asymmetric meter, I would choose for that top one. Okay. How about letter B? Mixed meter, very good, because you can see how quickly the meter signatures are changing. Letter C, I think, is a very poor example. I would probably not give you one like this. I would make it a little clearer. Yeah, it's actually added value. But, you know, if I take the first measure kind of like as my starting point, and I compare the second measure, and keep comparing the third measure and fourth measure to the first measure, there's a lot of things that are different. It's not just one thing that's been added. It's not just one thing that's been made it irregular compared to the beginning. So, I don't know, unless you guys see another way to look at that. I just think it's kind of a weak for example. Letter D, what are you going to say? Yeah, and what gives it away to you? Yeah, the rhythmic equation. And finally, letter E. Displaced accent, that's right. We're in 3/4 meter, the accents are placed on either beat 3 or beat 2. When beat 1 is normally the strong beat. Yeah.
So just to mention that, even if it is like the displaced accent, is it still not retrogradable rhythm since it's straight forwards?
You mean like this example here?
Yes.
That's a good question. I'm not sure that the non-retrogradable rhythms have been combined with the accent patterns. I would say certainly if you didn't have the first measure, and you just had the last 2 measures, I would say that's definitely non-retrogradable because they're all in the center, so they would all sound the same. But if you perform this one backwards from right to left, the accent's certainly going to be in a different place when you get to that measure than you played with the first one. So.
Also, what's the non-metropolitan, doesn't have to be within one measure?
Nope, it doesn't have to be within one measure, it can span across multiple measures. Yep.
Okay, so can it sound something different? Like when I have like an eighth rest and then we have a tie, and so it's like, would it sound the same like
Typically not. I mean, I would say maybe like, for instance, you could do, technically, I guess you could do something like this, although I don't know why you would, but. Because I guess this technically sounds the same, way backwards as forwards. But yeah, if you're gonna substitute, if you have a rest in one place, and then you have a tie in the other place, I know there's something not sounding, something is not being articulated, but there still is sound rather than absence of sound. So I don't know if that's exactly correct. Yeah, I would be careful. The best way to do the non-retrogradable rhythms, and really the book doesn't really, and the workbook, they don't give you anything very difficult, is just to make it look symmetrical. That's the best thing to do. Okay, so let's go to section B here. Out of those 4 rhythms, which of those are non-retrogradable?
Or
B
B.
and C.
Which ones?
B and C.
Yes, B and C are non-retrogradable because they sound identical when they're played forward to backwards. A is retrogradable. It's different when you play backwards. And D is retrogradable. It sounds different when you play it from right to left than when you play it from left to right. So I just want you to make it clear. It's not a hard concept, but don't get mixed up. C and B are non-retrogradable rhythms because they are exactly rhythm, pure rhythm palindromes. Another sheet still on here? Yes, I do. Well, I don't need such a question. I'll just verbally ask you a question. Let's look at this little piece of music. Just a couple questions about it. Which of the following rhythm devices is illustrated by this example? Is it asymmetric meter, is it composite meter, or is it mixed meter? Mixed meter, I would agree. You've got time signature change almost every measure. It's certainly not asymmetric meter because none of the top numbers of the time signatures are like 5 or 7 or 11 or 13 or anything like that. And it's not composite meter because we don't have something plus something over something in a meter signature. Make sense? What's that?
So crazy.
Yeah. Yeah, I'll tell you, a lot of 20th century meters you look at, some of it's going to be real crazy. Okay, what term is used to describe the immediate and proportional tempo change that occurs in the third measure? Say again? Metric modulation, that's right. If anything asks you about a proportional change in tempo and you see a rhythmic equation, that's metric modulation. Metric modulation. All right, let's go back and look at one other example now. This is from a different self-test. I really like application of these concepts a lot more than just discussing and talking about them. All right. See if we can do this together. This is a short piece, which I suppose I could find a report for. In fact, I do, but then you wouldn't be able to look at it and watch it go at the same time. So we'll just ask some questions about this 20th century piece. This is a piece by a composer whose last name is Payne. And I don't know if you get Payne by, or derive Payne by listening to this piece or not. But the title of the piece is Skipping. That's all it is. It's called Skipping. And one of the questions I want to ask you about this piece, this goes back a few class periods. Identify the scale on which this composition is based. Well, let's see if we can determine a tonic or a final to use to start our scale with before we take a pitch inventory? What note might you choose as the first note of the scale? I'm going to choose B flat, yeah. The first note is B flat, the very last bass note is B flat, okay? So I'm just going to start my pitch inventory with a B flat. Now, just find any other pitches that you can and tell me what you got. Okay, C, D, I see up there's a D. Okay, F. I think there's one other pitch in G. Yeah, G. That's right. Sorry, with the mouse on, it's hard for me. Are there any other notes besides these? Is there what? I don't think there shouldn't be any other pitches besides those. Okay, so what scale are we thinking of based on how many different pitches we've got? Yeah, there's 5 different pitches. We're thinking of pentatonic scale. Can you be more specific as to which? Yeah, the major pentatonic scale, right? Because its scale degree is 1, 2, 3, 5, and 6 of a major scale. Hey, how about that? You've identified the scale basis or the scale source in this little tone-centric composition. Way to go. Give yourself a pat on the back. Okay. What is the yeah, okay. If I had to add, and we just basically talked about this, if I asked you, what is the tone center, or what would you say the tonic is at the beginning of the piece? I would say B flat. That's right. What is the most prominent melodic interval in this composition? In other words, not a vertical interval or harmonic interval like that. What's the most prominent melodic interval? One that you hear 2 notes successively. Well, give me something like, was it a major 6? Is it a right 12? Yeah, I would say a perfect 4th. Very good. You know why? Because I can see perfect 4ths all throughout this repeated bass line. It's just B flat C, but C, F, C, F, C, F, over and over and over again. Look at all the perfect 4ths in the melody. The first interval, F to B flat is a perfect 4th. C to F is a perfect 4th. Look at all these C to Fs again. Look at this perfect 4th now, G down to D. There's perfect 4ths everywhere in this piece. So the perfect 4th is a very prominent interval that the composer wanted to use in this passage. Okay? Let me ask you this. What is the final chord of the piece? How would you analyze it? Say again? No, I would say it's a quintal chord, right? D flat to F is a perfect fifth, F to C is a perfect fifth, and C to G is a perfect. Do we need to call it like a 1-6 or a 5-7 or a 5? No. We don't use any Roman numerals or functions and stuff. I would just say it's Q5. It's a quintal chord. Yeah, I know, we should use maybe Q, but you know what? A quintal chord, Q5 is the inversion of Q4. Because the fifth is the inversion of the fourth. So maybe there's some coherence and connection here. Lastly, this is a real easy question. Are there any accidental music that were used in the piece of it? No? Not a single one. So it's strictly built on and based on that major pentatonic scale. All right, let me try one more thing before we go. I want to see if I can get this to sound. For that, I got to change the input source once.
self-test, 26 to C.
This is skipping. Does it kind of sound like skipping? There's the principal. Yeah, isn't that neat? It's certainly different than a lot of the music we focus on. But that's what you get when you start experimenting and do a 20th century concert. Yeah, his name, last name is Payne, P-A-Y, and it's called Skipping. Yeah. Okay, so I think that's about where we're going to have to stop today. You should have all the tools you need now to complete your rhythmic homework in the workbook for Monday. And on Monday, we're going to start atonal music, that is music without a tonic at all. Okay, have a good weekend.